All right, these notes today are about section 4.2. And so it starts off by talking about a polynomial that has a degree n. The graph of the function has at most n real zeros, and or that will mean the same thing, that it has at most n x-intercepts. And then it has at most n minus 1 turning points. Now what this means is, let's just think about a quadratic. All right, a quadratic equation is going to be something, let's say we have a polynomial p of x equals blah, 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 and we know that it's an x squared and it plus blah, blah, blah. Okay, so the degree of the polynomial would be 2 if it was a quadratic. And so a quadratic is a parabola when you graph it. And so the parabola may look like this, and it can cross the x-axis here and here, so it would have 2 zeros. But it might just touch it like this right here, okay? Then it would just have 1 zero. Or maybe it's up high, somewhere like this, and it doesn't even touch the x-axis. So it would have no real zeros, it would just be imaginary. So what this is telling us is, whatever the polynomial is, we look at the degree, then it's going to have whatever the largest power is, which is the degree. That's the most real zeros that it's going to have, all right? And so then it's going to have at most n minus 1 turning points. So like on this one I drew first, it has 2 real zeros, okay, across the x-axis in 2 places. Well, how many turning points does it have? 1. It comes down, it changes directions, and it goes back up. So if the degree is 2, it's going to have at most 1 turning point. And the way you get that is you would just do, if we're talking about quadratic, it would be whatever the degree is, which in this case was 2 minus 1, and we would get 1, right? So this is really easy questions, but I want you to understand the concept of what it's saying. So this says, find the number of zeros and turning points possible for this function. So this is a cubic function, all right? So the degree is 3. So that means we have at most 3 real zeros, and that means at most 3 x-intercepts. And then for turning points, we have at most 3 minus 1, so that would be 2 turning points. Okay? All right, so now this looks like a lot. Okay, don't forget about all of this writing. But we're going to be graphing polynomial functions, and really we're going to be using the graphing calculator for most of this. But we're going to look at the leading term test at the end behavior, what it tells us. We're going to find the zeros, and there's lots of ways to do that. We can factor, we can do the Casio and do modify 3, modify 4. We can use the app button in the graphing calculator. We can actually graph it and find the zeros. So lots of choices there. We're going to use the x-intercepts, or the zeros, and that's going to divide the x-axis into different intervals. And then we're going to choose a test point to determine the signs of all the function values in that interval to tell us if it's above the x-axis or below the x-axis. We're going to find the y-intercept, which is f of 0. So when you plug in 0, that gives you the y-intercept. And then, if necessary, we're going to find additional function values to determine the shape. So really, what we're going to find in the graphing calculator is we're going to find any minimums or maximums that the graph may have. Okay. And then as a partial check, we're going to use the fact that the graph has at most n x-intercepts, or at most n minus 1 turning points, and then we may look at the multiplicity, okay? And so then we can actually check with the graphing calculator, and this is really what we're going to be doing, okay, to find a lot of this stuff. So there's a lot of stuff here. After we get on into it, we probably won't be doing quite as much. We'll be just relying on the graphing calculator for most of it, okay? But for the first couple, we're going to go through the whole 9 yards. So right here, here's my function. This is a quartic, not that it asks for that, but because it's x to the 4th, it's a quartic. So the degree is 4. The leading term test. this is an even exponent, which is my degree. And so I know the ends go the same direction. Because it's negative, they both go down. Okay, now it may go up and down in the middle, but the ends are going to go down. All right, then we're going to find the zeros, or the x-intercepts. Now we can do this by putting it in the calculator, graphing calculator. We can put it in the Casio. Actually, we can't do this one in Casio because it's 4. So what we're actually going to do, this one factors pretty easily, and that's how we're going to do it. So I'm going to take this, negative 2x to the 4th plus 3x cubed, set this equal to 0. Okay, what do these have in common? They both have an x. And actually, I can pull out 3 x's. So this is x to the 3rd is going to come out. That's going to leave me negative 2x plus 3. So it's factored. Now you set each one of these equal to 0. So x cubed equals 0. If I take the cube root, I'm still going to get x equals 0 because that's what it is. And so then here I will set this equal to 0. Negative 2x plus 3 equals 0. So negative 2x equals negative 3. X equals 3 over 2, or 1.5. All right? So these are the zeros. That tells me I have a 0 here. There's a 0 right here, a 0. And then there's 1 at 1.5, or 3 over 2. Okay? So that's my 2 zeros that I see. Now, the signs of the intervals. All right, this is not hard. It's just a little tedious. Okay, so I have graphed these zeros. It splits the x-axis up into 3 sections. I have the left section from negative infinity to 0, the part between 0 and 1.5, and then 1.5 to infinity. All right, so I've got negative infinity to 0, then I have 0 to 1, and then I have 1.5, sorry. And then I have 1.5 to positive infinity. Okay? Now, I'm going to pick a test point to plug in here to and the test point, the sign of the test point, the result that I get is going to tell me if the graph is below or above in these intervals. Okay? So, test point. All right. You can't use, I can't use 0. I have to use something less than that. So, I just said, let's try negative 1. And between 0 and 1.5, I chose positive 1. And then for a number larger than 1.5, I chose 2. Okay? So, these are my test points. Now, what you're going to do is you're going to take this number, negative 1, and you're going to plug it in for x. All right? So, when I go up here, like if I come over here and that's all right, negative 2 times negative 1 to the 4th power plus 3 times negative 1 cubed. When I work this out, and you can just type all this in your calculator or do it by hand, this is going to be a positive 1, so this is negative 2. This gives me negative 1 times 3, which is a negative 3, and so I get negative 5. So when I plug in negative 1, I get the result of negative 5. All right, now, all I need to know is that this is a negative number. So that tells me the graph is going to be below the x-axis. So all the values that are in this interval from 0 to negative infinity are going to be below the x-axis. Okay? Now, when I plug in positive 1 up here, I did send a different color. This would be negative 2 times 1 to the 4th plus 3 times 1 cubed. And so this is really just negative 2 plus 3, and this equals 1. And so 1 is a positive number. And so positive means it is above the x-axis. So all the values between 0 and 1.5 in this interval are all up here above the x-axis somewhere. All right, now plug in 2. So I put that in red. So I have negative 2 times 2 to the 4th plus 3 times 2 cubed is so I work this out. This is negative 2 times 16, which is a negative 32, plus 2 cubed is 8. 8 times 3 is 24. Excuse me. And this gives me a negative 8. Okay? And so, since this is a negative, it tells me that it's going to be below the x-axis. Right? So, I know that this graph is down here somewhere, then it goes up here, and then it's back down here again. Okay? That it doesn't just come up here and touch, and then turn around and come back down. All right? Now, the y-intercept, you find the y-intercept by plugging in 0 for x. And so I'm going to have, I have negative 2. I'm just going to write right here, plug in 0. So this would be negative 2 times 0 to the 4th plus 3 times 0 cubed, and this equals 0. So the y-intercept is the ordered pair 0, 0, because I plugged in 0 and I got 0. So that tells me, well, I have this right here, obviously. It's 0, 0 is the y-intercept, okay? And so then the turning points, I realized that this degree is 4. So 4 minus 1 equals 3. And so there's at most 3 turning points, okay? Now, another thing it said in that list was to find the minimums and the maximums, or to find any other important points, and so that's what we're going to do. So I'm going to get my graphing calculator, and I'm going to type this in. So I'm going to type in negative 2 x to the 4th plus 3 x to the 3rd. All right, and so I hit graph. It's going to draw it, and you may not can see this, but if you'll just graph it in your calculator, it goes up and then it kind of comes over here a little bit and then comes back down. All right, so it has a maximum point up here where it's turning and coming back down. So that's the point I want to find. It doesn't have a minimum, so it just kind of goes over this way and down. So I'm going to hit second trace. Maximum is number 4. Now, it's going to ask me left, right, and guess. So I'm going to move my cursor to where I think that high point is in the graph. Okay. And so now it says left bound. So I'm going to go to the left side of the maximum value. So I hit enter. Now I'm going to go to the right side of that little hump, that little mountain peak, and hit enter. And now guess, I'm just going to try to get it on where I think it is. So, and hit enter. And so I get this decimals. All right, so this is, I'm just going to round it to 2 decimals. So I get 1.13, comma 1.07. All right, so that's an important point I'm going to write down. I'll put it down here. Okay, so the maximum is at the point 1.13, comma 1.07. That's the maximum. So now I'm going to come over here and graph that. So 1.13, that's a little past 1, and then just a little bit above positive 1, so it's like right here. It's almost 1, but not exactly. So now, since I have found these points, because I plugged in a test point, let's try to use them. 1, -5, I know is on the graph. So -1, -5, I should say. So it's right here. And then I found the point 1, 1, which is like right here, got this. And then I found the point 2, -8, and I can't go down to that, but somewhere down here, there would be another point. Okay. So this graph, then I just sketch it. It's going to come up here like this, and then it's going to come back down like this. And so there's the graph. Now, we did this, okay, but really, because of the leading turn test, we knew it was going down here and down here. And so when we factored this, we saw that 0 is a 0, and the multiplicity was 3. So we knew that it was going to cross the x-axis there because that's an odd number, and that's what we saw in section 1. this is a factor, this is to the first power, and so this is only used as a factor once, so we knew it was going to cross here. So really, we didn't need this to show us that the graph is going to be down here below the x-axis in those two intervals and up in the middle. We could get all that from just using what we already knew about leading term test. But the book goes through this process, and so you may see some problems that ask you about it. So I wanted to work, I'm going to work this one and the next one using it. But a lot of what we do, this is not necessary for us to do. Okay? All right. Next one. So this is a cubic. Because it has degree 3. So since this is an odd exponent, that means it goes opposite ways. This is positive 2, so it's going up on the right. So it's going to be going up here. Now, we're going to find these zeros. You could put this in the Casio and do modify 4. You could type it in the graphing calculator with the apps key and put it on cubic and type in ABCD, and it would tell you the answers. You can graph it. This one factors, so that's what I'm going to do by hand. So I'm going to group this together. And so you say, what this 4 terms, so I group the first 2, group the last 2. What do these 2 terms have in common? An x squared. And so that's going to leave me 2x plus, all right, x squared, we're going to x squared 1 time, all right? And so I put a 1 here. I can't leave it blank because I have to be able to distribute this back and get what I started with. So it's like saying 5 will go into 5 1 time, 5 over 5. All right, so right here, -8 and -4, what do those have in common? A -4 will go into both of those, so I bring out -4. That's going to leave me 2x, and then -4 divided by -4, there again, is a positive 1. And so these two parentheses match, which is what I needed to happen. And so now I have 2x plus 1 times what I have left is x squared minus 4. And this all equals 0. Okay, so I'm finding the zeros. So now, I set both these parentheses equal 0 and solve. So I have 2x plus 1 equals 0. And then I'm going to have x squared minus 4 equals 0. So subtract 1 here. 2x equals -1 divided by 2. X equals -1/2. So there's one of those zeros. Over here, add 4. I get x squared equals 4. Take the square root. So I have just an x. So x equals plus or minus 2. So the zeros are -1/2, and then -2 and +2. Okay? All right, now the signs of the intervals. So we did this again. This will be that we do like this. All right, so we have the left side, which is -infinity to -2. Then we have from -2 to -1/2. Then we have from, I have to erase this. Then we have -1/2 to +2, and then we have from +2 to infinity. So these zeros divided the x-axis into 4 sections. Okay. So this is my test point. So I picked -3. Between -2 and -1/2, I picked -1. Here I picked 0. I always use 0 if you can use it. And then something bigger than 2, I chose 3. Now basically you're going to take these numbers, plug them in for x, work it out and see what you get. So when I plug in -3 for x, I get -25. So this is a negative, which means that it is below. When I plugged in -1, I get a 3, and so that's a positive, which means above the x-axis. when I plug in 0, I get -4. And so this is the negative, which is below. And then when I plug in +3, I got 35, which is a positive number, and that is above. Okay. All right. Now, y-intercept, I've already found it really. When I plug in 0 for all my x's, it's 0, 0, 0, and 84. So I'm going to plug in 0 so you don't forget. And you're going to get -4. So it's the ordered pair 0, -. Yeah, 0, -4. So it's going to be right here. It's the y-intercept. Now, turning points, since this is a cubic, it has at most 3 minus 1 is 2, so at most 2 turning points. And now I'm going to find this because I'm going to find any minimums and maximums. So I'm going to graph it. Okay, I'm going to go to y equals, clear this out, and type this in, 2x to the third plus x squared minus 8x minus 4. So I graph this. So it's a graph that's doing this and coming back up. All right, so it has a maximum and it has a minimum, or relative maximum and minimum, I should say. So I'm going to do second trace, and I'm going to find the one on the left, which was the maximum first. It doesn't matter which one you do. So I'm going to move my cursor to that hump on the maximum point, which is the hump. So I go to the left. Now I'm on it. It's asking me for a left bound, so I need to go over to the left side of the little mountain peak or hump. Okay, press enter. Now I want to get just to the right side of that hump. I press enter. Now I want to try to get on the top of it if I can. Sometimes you can't get real close. Press enter. It gives me -1.3 repeating, and then 3.70. All right. So the maximum is -1.33. 3.70. All right, now I'm going to go back and I want to find this minimum value down here. So I'm going to do second trace. Minimum is number 3. So I got to move my cursor over here to this low part. All right, so it says left bound, so I'm going to go to the left, even though I can't hardly see it because of all the writing down there, but I know I'm to the left of it. So I press enter. Now I'm going to go to the right side of the little valley. Right, press enter, then try to get on the low point, press enter. So I get, it's about 1, all right, and this is, so I guess it's 1, -9. Yeah. So the minimum is 1.00 and then -9. Okay, so then I'm going to write that. Come over here. -1.3 up to 3.7, so it's right here. And then 1, -9 would be here. And so then I try to sketch this. So up here, down, back down here. So that's the graph. Okay. Now, even though we did this, we already knew that it was going to be below on the left side, above on the right side. And none of these, I didn't have anything raised to more than 1 power. So the multiplicity of all of these factors was just 1. So I knew it was going to cross at those. So really, with all the technology we have, I think that this is not necessary to do this. And so, but I have showed you how to do it. We've done 2 problems. And so I'll check that off, and then we probably won't do it anymore. Okay. All right, now, this one is x to the 4th. So this is a quartic. So we're going to do this one in the calculator. Well, we'll look at the leading term. This is a even number. It's a positive, so both ends go up. Okay. Now to find these zeros, we're going to do it in the graphing calculator. So you're just going to graph it. So we're going to go to y equals, type in this polynomial, so x to the fourth, minus 7x to the third, plus 12x squared, plus 4x minus 16. All right, so now press graph. All right, so it looks kind of like a lopsided W. All right, and so now this is going down below my screen, so I need to adjust my window. So I'm going to press window. I need the y value to be lower. Okay, so I go down here where it says y minimum, and it says -10. So I'm just going to change it to -20 to see if that will do it. And now I go back to graph. And so that does it. Now I can see where the end of the graph is. Okay. So to find the zeros, we're looking to see where it crosses at. Now, this is one of those graphs where it looks like it is going exactly through the points. All right. So it looks like it's crossing at -1, 2, it touches, and then it's crossing at +4. Now I'm gonna double check this in my table. I just press second graph, and that gives you my XY chart. And so it looked like it was going through -1. See, I see a 0 beside -1, and then 2 has a 0 beside it. And when I scroll down, 4 has 0 beside it, so I was right. It was right on the money at those points. So I don't have to do left, right, guess, and all that stuff. I can just eyeball it and know, yes, that's it. Okay. So if you think that it's right on it, I would double check in the table, and if it is, then just go ahead and write that down and move on to the next one. So the zeros are -1, -2, -1, +2, sorry, and +4. All right. So -1, 2, 4. Now we'll say it crossed here and it crossed here, but at 2 it just touched. So this would be used as a factor twice. So if I wanted to factor this now in those zeros, I know that it would factor into x, to be the opposite sign, +1 times x minus 2, and I'd have it squared. That would be 2 times. And then this would be x minus 4. That would be how it would factor. And so there are 4 zeros. I have 1, 2, and this number here counts twice because it just touches a bit. All right, and so it adds up to be 4 for all of those zeros. Now the y-intercept, plug in 0. Excuse me. And so this is, you're looking for f of 0. So you just plug in a 0, you get -16. So it's the order pair of 0, -16. So it's down here. Okay. And now turning points, this is 4 minus 1. So there's at most 3. Okay. Now we're going to find the zeros. So I'm going to do second trace number, I'm finding the minimums and maximums. All right, let me just go back to the graph. It has a minimum here, so it has 2 minimums, and then it has 1 maximum, which is actually 2 where it touches. Okay, so I'll find this minimum and this minimum. So I do second trace, minimum is 3, and I'm going to find this one down here at the bottom, and it may be the y-axis. I'm not sure if it's exactly on it. So I'm going to go to the left side of the little valley, press enter, to the right side of the valley, and then try to get it on the lowest point, press enter. And so it's almost the y-intercept, but not exactly. And so the minimum value is negative, if I round to 2 decimals, it'd be -0.15, comma, -16.31. All right, so the minimum is -0.15, comma, -16.31. All right, I know that the maximum was right on 2 as a turning point. So the maximum is 2, 0. And now I'm going to find the other minimum. calculator. Second trace, number 3 is minimum. So now move it over here to this other one. All right, so now go to the left side of the little valley, press enter, right side of the little valley, press enter, and then I try to get it on the low point of the valley. So I get 3 point, it's almost 3.4, and then negative 5.17. So the other minimum is 3.40 and negative 5.17. All right, now I'm going to graph this. So negative 0.15, negative 16.3, this is about right here. So it's really very close to my y-intercept. And then the other minimum is 3.4, negative 5.17, so it's about right here. Okay, so this graph is coming down. It is here, comes up, touches at 2, comes back down, goes back up like this. Okay. All right, so that is graphing. And now this last little bit is very easy. This is called the intermediate value theorem. The hardest part is going to be remembering the name because what you do is really easy. And so what it says is for any polynomial function p of x with real coefficients, suppose that a does not equal b. Suppose that for a not equal to b, p of a and p of b are of opposite signs. So what they're saying is you have two numbers, and when you plug them into the function, you get two y values that are opposite signs. Okay, so let's just say that you plug it in and you get p of a and it's a positive number, and then you plug it in and your y, and the other y value is the negative. Okay, here's your x-axis. What this intermediate value theorem is saying then there's a real zero between a and b, because if one of them is positive and one of them is negative, then at some point between here and here, it has to cross the x-axis. So you've got a real zero somewhere there. That's what this is saying, okay? So if you plug in two numbers and you get opposite signs for the y values, then there's a real zero between there because it had to cross the x-axis. Okay, so this is really easy stuff. So what they're going to do, determine if possible if the function has a real zero between a and b. So they're going to give you a function, they're going to give you an a value and a b value, you plug them in, and you see if they have opposite signs or not. All right, so we have a is negative 4, so we're going to find f of negative 4, so you plug that in, this is our a value. So when we do, you would have negative 4 cubed plus negative 4 squared minus 6 times negative 4. And when you work this out, you're going to get negative 24. So you get the ordered pair negative 4, negative 24. And then when you do the next one, you're going to plug in negative 2. And so when you work this out, you get 8. And so that gives you the ordered pair negative 2, 8. So this is a negative. This is a positive answer. So yes, there's a real zero. Okay, so this means yes, there's a real zero between them. Now, just go through and plug these in, and so I'll just tell you what you should get for negative 1. When you plug in negative 1, you're going to get positive 6. And when you plug in 3, you're going to get 18. So for part B, you plug in 3, you're going to get 18, which is positive. Now, if you get two answers that have the same sign, and we're looking at the y values, what's the number we get when we plug this in? If you get two of the same sign, then this intermediate value theorem does not apply because it doesn't tell us anything. All right, so it does not apply. It's not no, okay? We don't know. It just means we don't know anything. All right, it's not telling us anything about it. So then you do this. So when you plug in negative 1/2, you're going to get negative 5 over 48. When you plug in positive 1/2, you get 7 over 48 is what it looks like on my paper. All right, so these are opposite signs. So this means yes, there's a real 0 between there. Okay, and so then this last one down here, if you plug in positive 1, you get 4/3. And when you plug in positive 2, you get 40/3. And so these are both positive. Basically, it doesn't matter if they're positive or negative if they're the same sign. So this is the same sign. So it does not apply. It doesn't tell us anything. It only applies if you get opposites. Okay? And that is it for this section.